Hi, and welcome to yet another video in AI and C# on the agent framework. And this video is, I call it multi-agents, but it's actually also tool calling and more advanced version of that tool calling, because what we're going to see is that we can actually have one agent use other agents as tools, um, meaning that they are just being given as tools, but it is an entire agent instead of just some code we have written. So let's get into it. And here we are in Visual Studio, and we are just making the normal client, and we are gonna make multiple agents. We're gonna make a string agent. So this agent is a string manipulator, and it have received 3 tools, which we can see in here. Just an uppercase tool that can uppercase some text, a lowercase tool, and a reverse tool. So nothing special in that. And then we are just adding the middleware so we can see what is being called. And this middleware tells, of course, what tool we are calling, but also which agent is the one calling it. Because now that we have multiple agents, it might be a good idea to know that as well. But else it's normal function calling, like in the video dedicated on that. Then we have a number agent that just can give a random number or a 42 number back. So just simulating 2 agents with various tools. And you can see there's only a few tools, but there could be many tools. Because one of the problems with tool calling is that if you end up with multiple tools, 20 or more, it begins to be hard for an LLM to choose among all these tools. And we send a lot of tokens up in that. And that is actually one of the reasons why you can do one of these things. But let's see that we now have these 2, but instead of just calling them, we're going to make a delegation agent. This is just a name I gave it. It's just an agent like normal. But instead of the tools like AI function create here and so on, which we're saying the string agent as an AI function with the name string agent as tool, and the number agent as a function down here. And then we are just having that delegation agent. And then we're calling it, and we ask it to uppercase hello world. So if we set a breakpoint and run this, we will be able to see what's happening. So right now we are in the scenario of the delegate agent. Let me move this over so we can run it side by side. And we are going to ask the delegate agent. So we saw now that it made a tool call to the tool called string agent as tool. So the other agent, and it was the delegate agent who did that. And it just took the query in hello world, uppercase hello world. And then we see another tool call, which is actually from the string agent being executed. So that went in and did the uppercasing by itself, gave the value back, and then gave that back to the delegate agent. So there's actually 2 agents in the works here, but we didn't do the second call. That was none of them essentially. We just started the agent, asked it to do it, and it did 2 tool calls, or it did one to an agent that then did another tool call. And we see now that it's hello world in capital letters, makes sense. And we can see it used 263 tokens and 49 output tokens. Now I'm going to show you what happens if we make an agent that just gets all of those tools instead of agents within agents. So essentially, it gets the same question, uppercase hello world, but now it's an agent that have all the 5 tools instead of 3 and 2, or it had 2 tools with 3 and 2 in it. So again, it calls uppercase because now it knows that it needs to do that. And what we see, and it's not too clear here, you can see that Jack of all trade that had all 5 tools used more tokens than the ones who had just the 2 tools with the other tools inside. This is only the tool calling from the outer agent. So we might say with this scenario, they are roughly the same. Perhaps there's even a bit more. But let's imagine that we had a bunch of tools. Get rid of this. And the way I can simulate that is to just take the reverse tool and put it in multiple times. Like this. It will essentially be the same tool, but the schema that the LLM will get will be the same. And if I give the same to this one, and in the same manner, I'm going to take this one. So again, these would be all kinds of different tools we were making instead of just copy pasting the same one. But this is just easier, quicker to do. And let me close this one and start again, because now we will see a more distinct difference in the calling size. So we call the delegate agent. It will uppercase like normal. And it used 263 tokens still, plus whatever was inside this one. But if we go to the second one, the Jack of all trades, we will see that that used 2000 tokens, because every time Jack of all trades are being called, it needs the schema of all the tools. Every time the delegation one is being called, it only needs the tools based on which of the 2 of these it needs. If it needs both of them, it will be the same, of course. But imagine you could group all your tool calls into multiple things and then put them in their separate agent. Then you can actually have more tools by being gated between groups. And that is the main reason you want to do something like this. So whenever we need to do something with string, we don't need to load up the schema for all this. We just need to load up the schema that we have a number expert. So that is the way you can do this. You can also, of course, also reuse different agents in this way, where you just may have a bunch of agents lying around in various areas, one string manipulator, and then you suddenly need it in another place. So you can use them that way. But that is actually everything for this one. See you in the next one.